So now that we've talked about formulas of compounds, let's talk about formula mass. The formula mass is the average mass of the formula of an individual molecule or of the formula unit. It is sometimes also called a molecular mass or a molecular weight. It's the mass of a molecule, the mass of the formula. Just like an atomic mass was the mass of one atom. So to find the mass of the formula, you just add up the masses of all the atoms that are in the formula. So the whole is equal to the sum of the parts. You write it all out like this and it looks more confusing than it's much easier than that. So some of these problems are going to give us a little bit of nomenclature practice as well. So here it says calculate the formula mass of calcium nitrate. Well, first we have to write the formula for calcium nitrate. Is this ionic, molecular, or an acid? It's ionic. The first element is calcium. We find it on the periodic table. It's a metal. Therefore, this is ionic. So we're going to start by writing the ions with their charges. So what's the charge on a calcium ion? 2+. And then nitrate. NO3, -1. As you're doing homework problems, working on the worksheet, don't just go look up nitrate. Try to remember what it is, write it down with the charge, then look it up and check yourself. You'll learn them faster that way. So how do I put these two together? I need 2 nitrates, right? So I need 2 of the polyatomic ion. I'm going to put parentheses like shrink wrap around it, and I'm going to put how many on the outside. So this is CaNO3, 2. When we read the formula, we don't read the parentheses. CaNO3, 2. If the parentheses weren't there, it would be CaNO32, right? So now we've got the formula. So in this formula, we have 1 calcium. How many nitrogens? 2 nitrogens and how many oxygens? 6 oxygens, right? So we've got the number of each atom, and we're going to look up the atomic mass for each on the periodic table and stick them all together. So there's 1 calcium, 40.08. 40.08, and this is going to be in atomic mass units. And there are 2 nitrogens. Those each weigh 14.01, and there are 6 oxygens, 16.00. Again, do not round your atomic masses to fewer than 4 significant figures. And if you're not sure, always keep more. It's always better to have more digits than not enough. It can get a little tedious, but the answer's going to be better. I forgot the unit there. So 40.08 plus 2 times 14.01 plus 6 times 16 equals 164.1 atomic mass units. That's the mass of the formula unit, the formula. Any questions? Yes? That's a good question. What's the difference between this and molar mass? We're also going to do molar masses of compounds, but that's the mass of 1 mole of the compound, and so the unit is gram. The calculation is exactly the same. This is the formula mass, and so looking at 1 formula unit. We actually don't use formula units or formula masses, that much. We usually use molar masses. What should we do with significant figures here? Well, we could be rigorous and go through and follow the rules. We've got multiplying and adding mixed together. It can get a little ugly sometimes. Here's my take on this. When you do these calculations, you never end up with a ridiculous amount of digits because we're not dividing anything. you're going to maybe end up with one extra digit. So I think it's best to just write down everything your calculator says. In the problem, it's probably some other measurement that's going to limit the sig figs on your answer. So I think that's just simpler. Just write down all the digits and leave it at that, okay? 164.10. Okay, so molar mass. The molar mass of a compound is the mass in grams of 1 mole of its molecules or formula units. It's the same number, but it's in grams. So let's do this one. What's the molar mass of ammonia? What's the formula for ammonia? NH3. Why? As you memorize it. Because Mrs. K said so. Okay, that's the formula. So we're going to calculate this in exactly the same way. So I have, in 1 mole of that, I have 1 mole of nitrogen atoms, right? And nitrogen atoms weigh 14.01 grams per mole. And I have 3 moles of hydrogen atoms, and hydrogen atoms are 1.008 grams per mole. So if I write it with units like that, then moles cancel out. So I've got 14.01 plus 3 times 1.008. 17.034 grams. That's the mass of 1 mole. That is equal to 1 mole of NH3. So sometimes they'll say calculate the molar mass, and you'll see 17.034 grams per mole. That's also correct, because it's the mass of 1 mole of ammonia. Any questions? So the molar mass combined with Avogadro's number can allow us to figure out how many molecules of a compound are in a particular mass. This is just like what we did counting atoms by weighing, but now we're counting molecules or formula units. You start with the mass of something, you calculate the moles, and that conversion there is the molar mass, and then from moles to molecules is Avogadro's number. So find the number of ibuprofen molecules in a tablet containing 200 milligrams of ibuprofen, and they give you the formula. This is my mom answer to any sort of pain. My throat hurts, take some ibuprofen. I sprained my ankle, take some ibuprofen. I have a headache, take some ibuprofen. My kids don't even ask anymore, they just say, where's the ibuprofen? Okay, so we've got a number there. This is really a unit conversion problem, dimensional analysis. So I have 200.0 milligrams. What am I trying to find? Find the number of molecules. We will need grams, but we need molecules at the end. So then we figure out, before we start writing stuff down, how am I going to get there? Well, we're going to go from milligrams to grams. And then grams, what's in the middle? Moles. Moles in the middle. And then moles to molecules. Sometimes it feels a little dumb to write this down, but getting the answer wrong is dumber, right? It's a learning tool. Do it a few times and then you don't have to write it down anymore because you'll do them correctly all the time. Just write down the path. Once you've got the path, everything else falls into place. It's following the pattern. So it's like Dora, right? Milligrams to grams to moles to molecules. So in my equation, I'm going to have milligrams to grams to moles to molecules. This is what I think is so stupid. Mole is a short word, it has an abbreviation. Molecule is a stinking long word, no abbreviation, got to write out the stupid thing. So milligrams to grams to moles to molecules. Put milligrams down here. I think some of you are still a little iffy on the dimensional analysis. Today would be a great day to figure that out. Cancel out the grams. Cancel out the moles. Units in first, then we put in the numbers. You can do the numbers, you can do the first, middle, last one, doesn't matter. I like to do the one that strikes me as being the easiest. And so maybe this one, the molecules in mole, that's Avogadro's number, right? Is it 1 dozen equals 12 eggs or 1 egg equals 12 dozen? 1 dozen is 12 eggs. The mole is the chemist's dozen. Molecules are chemist's eggs? I don't know. The number goes with molecules. And the number is that strange one, 6.022 times 10 to the 23rd.
When we say molecules, we're talking atoms.
No, we're talking molecules. Yep. So we're not doing individual atoms because this is a compound.
Right.
Yeah.
Okay.
The calculation looks the same except the word is molecule instead of atom. And where the difference comes in is when we calculate the molar mass. We're not just looking up the average mass of an element, we have to calculate it from the formula. This one in the middle is going to require a separate calculation, so I'm going to leave that one for the end. And here we have a metric conversion. What does milli stand for? Times 10 to the minus 3. So down here I have 1 milligram, and on the other side I write what milli stands for, 1 times 10 to the minus 3 grams. So some very strange things on worksheet 1, where you were supposed to write all of this out. That's graded and it's in the basket. You should pick that up and learn from it. Okay, the molar mass. This is what we just learned how to do. So I encourage you to do this separately and actually write it out, because it's really easy to make a mistake when you punch all these numbers in your calculator. If you have it written out down here, then you can go back and double check your calculator work very easily. And also, if you're getting something wrong, somebody else can help you figure out what's going wrong. So I've got the formula up there. So 13 moles of carbon times the mass of carbon. And then 18 moles of hydrogen times the mass of hydrogen. And 2 moles of oxygen times the molar mass of oxygen. Thank you. It's 18. I don't know where I got 14. I did that just to illustrate why you should write it down. Now I screwed up. 13 times 12.01 plus 18 times 1.008 plus 2 times 16. Calculator says 206.74. Nope. 206.274. I think my brain thinks it's Monday. What would the units on that be? Grams per mole. So we could write that grams per mole, or we could say that many grams equals 1 mole. This is my conversion factor that I'm going to stick in here. 1 mole of this compound weighs 206.274 grams. And yeah, it's probably got an extra 2 digits. Is that going to hurt anything? No. This has 4 sig figs, and that has 4 sig figs. This should have at least 4 sig figs. So it's okay to just let those extra 2 tag along. It's probably better that way. So I've got 200 times 1 EE minus 3 divided by 206.274 times 6.022 EE 23. Now, how many sig figs should my answer have? 4, because this one's got 4 and this one's got 4. This is exact. This one, it's at least 4. So 5.838. There's 4 sig figs. 83. And then look to the end of the number. It's very important not to leave out the times 10 to the 20th. Super important. That's more important than the stuff at the beginning. And then I can round this. 5.839 times 10 to the 20 molecules. Should I be expecting a really big number? Yeah. So 200 milligrams of ibuprofen, that's what's in a regular ibuprofen tablet. And there's other stuff in there too, but 200 milligrams is a visible amount. And so we should have a really large number of molecules. Any questions? Let's see if I got the answer right. Yep.